Ladies and gentlemen, we wish you a warm welcome. We are the founders of Bluepha. We are happy to invite friends all over the world to attend the Bluepha PHA product launch. This moment has been in the making for 6 years, and it was also eagerly awaited by our partners.
We are thrilled to officially introduce a global audience to Bluepha PHA, a groundbreaking sustainable product.
Next, I will give the floor to my partner.
Thanks, Haoqian. And I will start with the story of plastics. Have you ever wondered why people invented plastics? The invention of plastics is very interesting. It's not a story about inventing a material to produce footwear or packaging. No, it's not. It's a story about Billy balls. As a matter of fact, Billy balls were made of ivory from elephant tusks for centuries. In the 19th century, billiards became so popular that elephants were killed excessively for ivory to make billy balls. This placed wild elephant in a serious danger of extinction. Billy ball makers began to look for alternatives, offering $10,000 for new material with the same properties. In 1863, an American inventor named John Wesley Hyatt took up the challenge. And 5 years later, he invented a whole new synthetic material called celluloid. Since then, a brand new industry has been brought to the world that we all know today: plastics. The invention of plastics opened up a whole new world with countless possibilities for manufacturing. From automobile parts and telephones to jewelry, kitchenware, and shopping bags, plastics took the world by storm. Today, our daily lives are full of plastic products. They bring us convenience, but also serious environmental problems. The interesting point of the story of the plastic invention is that nowadays, people are talking about the environmental problems caused by plastics. However, at the very beginning, plastics are invented to solve environmental problems. Actually, plastic pollution has raised awareness worldwide, but it is not easy to solve. People talk a lot about how severe the problem is, but few of them can offer solutions. In this situation, everyone is both a participant and a victim. We are in a paradox of plastics. 6 years ago, we asked ourselves if there is a way out of this paradox. We believe there is one, even though it is difficult to approach. The only problem is that we humankind are not strong enough to find a harmony between human civilization and environmental impact. That's why we started Bluepha, which aims to empower human society to address the paradox of plastics. We think out of the box, keep going deep, and finally, find the answer. This answer is a gift from nature, rather than an invention of a new synthetic materials. It is a natural polymer found in the cells of a wide range of microorganisms. They use it as nutrition and energy storage. As part of nature, this polymer has been existed on Earth for billions of years. Technically, it is a kind of PHA, short for polyhydroxy or canoates. Commercially, we call it Bluepha or Lanjing in Chinese. Actually, Bluepha has been a part of nature for billions of years. What we did was to find an industrial way to mass produce it. We are like shepherd from nature to our home, bring a whole new world with countless possibilities for manufacturing sustainably. Therefore, Bluepha is a fabulous blend with nature, or should I say, a fabulous blend with nature. Tracing millions of years of human history, looking back to nature for answers is a common way. Just like ivory was used to make Billy balls. If we narrow it down to polymers, about 5 groups of natural polymers have been developed for massive use by humankind. All of these polymers are developed and used for thousands of years. Bluepha, a special type of PHA polymer, will become a new member among this natural material family. Unlike the other 5 groups of natural polymers, Bluepha is produced by microorganisms rather than plants or animals. And the microbial production process can be highly efficient with low environmental impact. It is also different from fossil-based plastics or synthetic fibers. Bluepha is bio-based. More importantly, it is not even like polylactic acid or other compostable materials. Bluepha can degrade both in natural and artificial conditions. Even though Bluepha has so many natural features, the development process is really a long journey. It took us 5 years to achieve mass production, just as long as John Wesley took to invent plastics. At this moment, I am proud to announce that Bluepha PHA is available right now. Today, we will go through 4 parts of Bluepha, from properties to applications and production processes. Apart from that, we will take this opportunity to show you our new factory. Also, we will reveal a surprise at the end of the event. Now, I'd like to give the floor to 4 of my colleagues. First, I want to invite Yuanbin to the stage.
Hello, everyone. Hi.
Hi.
Thanks, Tom. As mentioned before, Bluepha is a natural polymer. It's produced by microorganisms. And its scientific name is poly-R3-hydroxybutyrate co-R3-hydroxyhexanoate, or PHBH for short. Currently, we have developed 2 grades for commercial use. One is BP315, a flexible grade with a high comonomer content. And the other is BP330, a rigid grade with a low comonomer content. For the convenience of customer use, we can deliver our resins in powder and pellet form. And next, I'll take you through Bluepha life cycle. First, where does Bluepha come from? Bluepha is made out of sustainably sourced plant oil, which itself is derived from carbon dioxide through photosynthesis. And the plant oil is used as feedstock to produce resin via green microbial fermentation rather than petrochemical processes. Bluepha grades were certified to have a 100% bio-based carbon content by TÜV Austria, a third-party authority. That means your products made with Bluepha leave lower carbon footprints. In addition to the source and process, true sustainability must also deal with end-of-life issues. So, where does Bluepha end up? Well, conventional plastics are barely degradable. Bluepha can be degraded in all typical artificial and natural environments, such as industrial compost, home compost, lands, rivers and lakes, and even the ocean. And next, I'll show you Bluepha's performances of home compost and the marine environments, which are the most difficult tests for degradable materials. These tests were conducted by OWS, a Belgium-based leading testing institution. In home composting experiments, both grades of Bluepha fume samples were completely degraded in only 10 weeks. In the marine test, it only took 16 weeks to reach a biodegradation percentage of nearly 19%. These results fully confirm that Bluepha grades have excellent biodegradability. Beyond that, it can be recycled just like conventional plastics. Unlike other degradable materials, Bluepha offers more sustainable end-of-life options. It provides Bluepha with a wide range of applications with greatly reducing the carbon footprints. I believe you have seen the great potential of Bluepha, but you might be wondering, is it ready to supply? How's the quality and quantity? In the following video, our colleagues will take you to visit our advanced biorefinery in Yancheng, China.
Hello everyone, welcome to Yancheng. I'd like to show you around our first Bluepha factory. We name it BioFab 1. Only 1 year ago, where I'm standing now was still a vast reed field. Now we have constructed our first industrial-scale facility for Bluepha with a high standard, which is a result of tremendous effort of our talented engineers. Bluepha had planted 3 phases on 86,000 square meters land. The first phase, BioFab 1, is fully up and running now. It can produce 5,000 tons Bluepha resin every year. Based on our own technology developed in-house, the entire facility and each production process step has been carefully designed and verified. The overall layout of the facility is a U-shape, which shortens the distance between each production unit and improves overall operational efficiency. In different workshops, we introduce advanced technology and approaches such as magnetic levitation, reuse of recycled water, to minimize the energy and resource consumed. All these advanced features make BioFab a green factory.
好的产线设计只是第一步，要实现可靠供应，还需要现代化的运营管理体系。BioFab 1的核心团队都曾在欧洲、美国、日本等生物制造企业长期工作，拥有丰富的运营管理经验。从人员、设备、原料管理到操作规程、环保安全检验检测，蓝素力求在每一个维度上追求卓越。 根据 PHA 的生产工艺特点，我们已制定了科学严谨的工艺规程和标准操作规程，并将作业指导书细化到主要操作步骤和要点。biobased Fab1 的运营遵循过程控制原则，按照 ISO 9001进行质量管理，通过严格控制参数范围和中间体检测来确保工艺的稳定性，进而交付给客户稳定可靠的产品。
BioFab 1 is running smoothly now, and the construction of BioFab 2 is also on the agenda. Once it's finished, our new super facility can produce 25,000 tons Bluepha resin per year totally. Here in BioFab 1, you can see everybody working vigorously because all of us believe Bluepha is a sustainable material with a promising future. What we are working for is to deliver the value behind Bluepha to all of you.
Thanks, Minjiang. Hello, everyone. I'm Shirley. We expect BioFab 1 to supply steady volumes of high-quality Bluepha resins to our customers, hence realizing an infinite number of possibilities for phyllo applications. Bluepha shows excellent properties, including toughness, heat resistance, barrier properties. It can be used to make green packaging, cosmetics, fabrics, and other advanced applications. It would take longer than this presentation to name all applications that brand owners and consumers might be interested in. For such a fabulous vision, delivery material is just the beginning. We've received many requests from customers for processability, productivity, and final product performance. So we decided to provide a complete solution for you. First, we will optimize the material formulation to develop tailor-made products for specific applications. Meanwhile, to improve the processability and the mechanical properties, the molecular structure will be adjusted based on mechanisms. Finally, we will offer processing guidelines and solutions according to your demands, which have been verified during mass production. Here, in terms of mechanisms, I would like to share some preliminary findings with you. In order to improve the processability, the rheological curves of different grades of Bluepha have been studied. And we have developed an understanding of the typical characteristics of the corresponding system. In the future, we were able to get our customer to adjust the temperature and the shear rate, improve the processing efficiency by 50%. Another way to improve the processing efficiency is by increasing the crystallization rate. Here you can see typical states and a range of temperatures for some resins, such as degradable plastics, PLA and PBAT, for conventional plastics, PP and PE. But Bluepha has a special mass memory effect. In this region, we can make a trade-off between temperature and the crystallization rate. This allows us to speed up the crystallization by 2 orders of the magnitude and makes the material 30% tougher and 50% more transparent. The mechanical properties are related to the aggregate state. And Bluepha shows differences in crystalline structure at different temperature. Notably, large crystals provide strength, while small ones provide toughness. Due to this property, the size and the distribution of the crystals can be controlled. Then the strength and the toughness can be increased by 20% each. These results are just a small part of our work. We have scientists and engineers across disciplines working together to help you deal with the problems that may arise during the process. And hopefully, our team can help you shorten the development cycle and efficiently deliver high-performance final products. We will keep exploring in the biomaterial field to make our Bluepha better known. We also look forward to working with more partners in this industry. Two well-known experts in PHA industry also sent us their congratulations today.
Ladies and gentlemen, it's a privilege and a great honor for me to address you at this event to celebrate the launch of Bluepha Natural PHA. During the past 4 to 5 years, I've gotten to know the people from Bluepha as very dedicated and knowledgeable in the development of state-of-the-art product and manufacturing technology for the industrial production of its natural PHA polymers. This work resulted in the startup of a new 5 kiloton per annum manufacturing plant today, which will be expanded in steps to 75 kiloton per annum within the next 4 to 5 years. Now, natural PHAs replace traditional plastics in almost all known applications, but are also used for non-traditional plastic applications like denitrification or animal feed. However, the available PHA volumes are still small. The natural PHAs are environmental friendly since they are part of the metabolism in most living organisms, like humans, animals, plants, microbes, to provide them with nutrition and energy. Those PHAs are made by bacteria who use almost any variety of feedstock that is available in nature. Natural PHAs form the most versatile material platform in the world, in performance, in application potential, and in end-of-life options. Circularity. There is a famous Chinese proverb saying, every material has its own way to be used. This is also true for the materials we talk about today. Also, these materials comply with all 6 possible end-of-life options, since they are used as a technical and as a nutritional ingredient, so the carbon is never spilled. Also, Bluepha has its focus on a large variety of one-time use and durable applications, and works closely with partners in the market to broaden their product coverage. Now, between 2021 and 2027, the natural PHA market shows a compounded annual growth rate of more than 50% each year, 50. So volume growth can hardly go faster than that. It means that it will still take 10 to 15 years until this new product platform will be a mainstream material. Bluepha is one of the early movers with the opening of its first industrial plant for the production of such PHAs. Today, demand for natural PHAs exceeds supply by far. Now, to become a mainstream material, the global production volumes need to be 100 times higher than they are today. Supply-demand needs to be in better balance, and the material needs to become cost competitive with traditional plastics. Economy of scale, manufacturing process technology advancements, and sufficient production capacity bring natural PHAs to cost and price competitiveness over time. While already more than 60% of the plastic market today can technically be replaced by products from this new material platform. I wish Bluepha a lot of success with their new business, and thank you very much for your kind attention.
大家好，我是陆英轩，非常高兴代表中国书写降解塑料专业委员会和大家一同分享蓝树 PHA 产品上市的喜悦。我和李腾、张航谦博士约在10年前相识，他们对生物降解材料孜孜不绝的热情打动了我。在他们的努力下，在过去的6年中，南京已经成为中国生物降解塑料产业中冉冉升起的新星。塑料因重量轻、性能优异、耐用性高而被广泛的使用，极大的方便了人们的生活。我国塑料工业发展非常的迅猛。据统计，2021年中国塑料制品表观消费量已经超过了1亿吨。然而，塑料制品在快速发展的同时，如何对其进行合理处置也遇到了一些挑战，尤其是大量的一次性塑料制品在使用和废弃以后，因处置不当而引发的环境污染问题也成为了全球关注的焦点。世界各国纷纷出台政策，宣布禁止或限制不易回收、易污染的一次性产品。生物降解塑料在这种背景下面越来越受到了广泛的关注。目前全球生物降解塑料产能已经超过200万吨，年复合增长率超过了 20%。 作为生物降解材料典型的一种材料， PHA 以其非凡的环境降解性能见长，尤其是 PHA 除了可以工业堆肥以外，还可以在自然环境、土壤、将近堆肥条件下面生物降解，这对于极进入或者泄露进入到自然环境的塑料污染物的替代尤其重要。 PHA 在上个世纪80年代被研发生产以来，一直被认为是最具有发展潜力的新型生物降解高分子之一，被工业界所看好。尤其是在双碳战略背景下面，国家有关部门发布了塑料污染治理、生物经济发展“十四五”规划和一些政策。那么生物降解塑料逐渐进入了可持续、理性、有序、健康、快速发展的阶段。相信在这种背景下面， PHA 发展也将迎来更好的前景。开发 PHA 材料并使其成功商业化并非易事，但南京已经克服诸多的困难，成功的建立了蓝树 PHA 工厂并投入运行，这无疑给行业增添了更多的信心，更加极大的促进实现 PHA 的产业化，加速实现低成本的生产技术。期望蓝树 PHA 未来能够应用到更多的场景，走进更多人们的生活，使得可持续的发展与人们美好的生活融为一体。谢谢大家。
Thank you, Mr. Laffenstein and Dr. Wen, for these encouraging words. Now it's time to reveal the surprise. Some panelists may ask whether Bluepha is a sustainable answer. As we all know, the global demand for plastics reaches hundreds of millions of tons per year. This raises the question, could we produce this huge amount of Bluepha without bringing new problems to the world? Then we need to take a deeper look at this question. According to the environmental benefit and technical difficulty, all the carbon sources for biomanufacturing can be divided into 3 generations. The first generation of them is traditional biomass, such as starch and plant oil. They are not only used in most biomanufacturing scenarios today, but are also important food sources. This would create a social dilemma, and we are determined to prevent this from happening. The second generation is non-food biomass, such as used cooking oil and straws. Their environmental cost is much lighter than that of the first generation, but it is so difficult to collect, transport, and process them. Therefore, further efforts are still needed for years, maybe decades. The third generation is greenhouse gases, including carbon dioxide and industrial waste gas. It envisions a supply chain that is independent of biomass, making a great contribution to the carbon neutrality. However, in terms of technology and engineering, it is extremely hard to effectively use them in this state of the art. So, what should Bluepha choose? Of course, the third generation. We always choose to do the right thing rather than the easy. We invented a brand new technology. It combines carbon dioxide with biomass as feedstocks to manufacture Bluepha. We call this technology biohybrid, just like hybrid cars. Then, how did we do it? Again, by learning from nature. The greatest challenge to use carbon dioxide as feedstock is the lack of energy. Nature solves this problem by a well-known biological process called photosynthesis through machine learning and metabolic profiling. We found that a considerable amount of energy is accumulated intracellularly when microorganisms consume plant oil. This energy is quite similar to that harvested in photosynthesis and also effectively driving carbon dioxide fixation, thus directly transforming carbon dioxide into our Bluepha. That is why we call it biohybrid. To date, we have completed the pilot test of Bluepha production based on biohybrid technology. Results showed that nearly 10% of the carbon atoms in Bluepha come from carbon dioxide. In the next 24 months, we will be able to deliver biohybrid-based Bluepha resins in large quantities. Actually, we will not stop here. We share the same value with our customers and would like to help them reduce the carbon footprint step by step. We will keep working on biohybrid in order to progressively increase the proportion of greenhouse gas carbon in Bluepha. So here we promise. We promise to increase this proportion to 20% by 2027. And our ultimate goal is to reach 100%. You may still have a concern that whether biohybrid would change product properties. Don't worry, you don't have to compromise between the material performance and the carbon footprint. More importantly, as a fundamental technology, biohybrid can be applied to almost any biomanufacturing process. Therefore, in the future, it can be used to manufacture various chemicals and materials that our customers need. Today, it's really exciting for us to introduce Bluepha, a new group of natural polymers. It can be integrated into countless scenarios to add remarkable sustainability benefits. It's only limited by your imagination. Starting today, Bluepha PHA is ready to supply. You can visit our website and leave your contact information. Our expert will get back to you and offer more information and technical support. Also, Li Teng and I would like to sincerely invite you to visit our plant on site.
We know it is impossible to address the plastic problem with one single company. And there will be multiple solutions. We are always open-minded and willing to work together with everyone for a sustainable future. So, let's work together for a fabulous blend with nature.